Hey, hey! We're now on lesson number 3 of graph transformations. If you remember, there are 6 transformations that you need to know in higher, and this is the second, y equals f of x plus or minus a. To introduce this, I want to go back to a basic trig graph once again. If you remember from National 5, you had to graph y equals sine x. That was nice and simple. Sometimes though, you had the x in brackets and it was plus or minus another number. For example, you might have had x plus 30 or x minus 30 or x plus 45. If you write it in that form, if you have x plus or minus something, such as 30 degrees, it is known as a phase shift. This 30 will be a phase angle and it moves the graph to the left and the right, or the right. If you have a plus, it's going to move the graph in the negative direction. So plus 45 would not move up to 45, it would move it to the left 45 degrees. If you have a minus, then the minus is going to move it in the positive direction. So an x minus 30 would move it 30 degrees to the right. Let's try this then. For an example, let's go with y equals sine of x minus 30. To do that, you know that every single point, the negative moves it in the positive direction, and every single point will move 30 degrees to the right. Take the main points here, so 0, 0 will move across to 30, 0. This point at 91 will be along at 120, and then 1. And then 180, that's also moving over. This is moving over, this is moving over. All the points move over, you've still got the same shape, and your graph will look something like that. So that would be sine of x minus 30. A lot of the time for the questions, it does ask you to sketch the graph between 0 and 360. So even though your starting point's moving over here, make sure you're still drawing this line in as well. It's true for any function. If you have f of x plus or minus some number, then it's going to again move it to the left or the right. So if you have some function, adding or subtracting to the x within the brackets shifts the graph to the left or the right. Same rule applies, a plus moves it in the negative direction and the negative moves it in the positive direction. Let's try an example then. So example 1, here's the graph of y equals f of x. Sketch the graph of y equals f of x plus 2 and label the key points. So with this one, we've got our 3 key points here. We've got 0, 0, 4, negative 7, and 6, 0. If you are to sketch y equals f of x plus 2, remember it's in the brackets, it's a positive, so it's going to move the graph in the negative direction. So all these points will be moving to the left. If you move them down the way then, let's do that as a dotted line, so that's the original. Move the graph, it's going to keep the same shape, but it'll just be over to the left slightly. Think about the points then, so 0, 0, well it'll now be at negative 2, 0. It'll be crossing the x-axis at negative 2. Instead of crossing at 6, it'll be crossing at 4, and this point with 4, negative 7, well if you move it 2 to the left, really you're taking 2 off the x value, so you'll be at 2, negative 7. And that is what you will get. If you look at the graphs side by side, you can see that the one on the right has been shifted 2 units to the left. Maybe best looking at it like that to see the difference. Let's try another example. Example number 2. So express x squared minus 8x plus 16 in the form x plus p all squared plus q. Hence sketch the graph of that. So the first thing you want to think is, how do you write it in that form? Max, I can see you jumping up and down. What would you do? Yes, it is completing the square. Well done, Max. And if you complete the square, what you do is you half the coefficient of x. So negative 8 halves to negative 4. So you'd end up with x take away 4 all squared. That's what that would be like. After you do that though, you have to remember your correction number. So if you square negative 4, you would end up with plus 16 and you take it away. So you take away the 16. This correction number you always take away, whether you've got a plus or a minus in here. So we're taking away 16, and then this positive 16 we just keep on the end there. Simplifying that, negative 16 add 16, that's right Olivia, it is 0, and we don't even need to write it. We could just have x take away 4 all squared. Brilliant. So That is us written it in that form, and we want to then sketch that. Remember your basic quadratic. If you have y equals x squared, then it's going to be a smiley face, woohoo, and it passes through the point 0, 0. So y equals x squared looks something like that. However, instead of x squared, we have the x in brackets and there's a plus or a minus. And in that case, just remember what we've been doing, it's going to shift the graph to the left or the right. The negative is going to move it in the positive direction. So this graph will move 4 units to the right. And it'll look something more like that. And that's what you would get. What you can also do with this is you could also find this point that it's crossing the y-axis. And when does it cross the y-axis? It's when x is 0. So we have y equals x squared take away 8x plus 16. That is the function that we have. We rewrote it as x minus 4 all squared. If you replace x with 0, you could do it in either of these equations here. Let's just use the second one. So we've got 0 take away 4 all squared. That becomes negative 4 squared, which is 16. So you know the point there is going to be 0, 16. What we could also have done is use the top equation. It's probably would have been a bit easier. It's just 0 squared, take away 8 times 0, and then plus 16. Really, it's just leaving us with the 16. But that is where it would cross, and that would be the graph. Really, when you do graph it, a lot of the time you would say where the graph crosses the x or the y axis. Looking at the two graphs side by side, again, you can see that we're starting off with this red one. If we shift it 4 places to the right, you'd end up with that graph there on the right. Give these questions a shot, see how it goes. It is in the Heinemann Higher, page 38, exercise 3E. Give it a shot, see how it goes. Have fun.